Hi, my name's Daniel,
This is Luke Thomas.
and we decided to do problem number 3. So for problem number 3, it asks to sketch the following graphs. Be sure to describe all aspects needed to accurately construct your sketch. Make sure that your axes are properly labeled with numbers and units. And we'll go on to letter A. So letter A, a wave travels to the right at 1.5 meters per second. The snapshot graph of the wave is shown at t equals 0 seconds. Now, for the first part, it asks to sketch the snapshot graph of the medium at t equals 4 seconds if the end of the medium at x equals 10 meters is fixed. So this is our graph for A, as shown here. It's this graph right here. So we're given that the object is moving, that the wave is moving, traveling to the right at 1.5 meters per second. So, and for the second part, it asks us, and it also gives us that the medium is at t equals 4 seconds. Based on the velocity that we're given and the medium that we're given, we're able to find the displacement, which is 6 meters. So in a way, we are restarting our graph at x equals 6 meters. So as you can tell here, it starts from x equals 6. This same sort of shape right here, this triangle. It starts at x equals 6, and it goes and it goes, and it keeps going until 10. When it comes to 10, we are told when it comes to 10, naturally the wave would have to reflect back, but since it's a fixed point, we would have to inverse it as well as reflect it. So as shown here, this part of the graph is inversed and reflected as well. As you can tell, this is the part of the graph that is being inversely reflected as well right here. And so now it also asks us for the superposition. So to determine superposition, all we do is look at each single one of these points. So 4, 5, 6, 7, 8, 9, 10. And we basically add or subtract whichever points they make. So for example, for x equals 6, it's 0 because both points are at 0. Now for x equals 7, it's plus 1 right here and minus 1 right here. So the superposition would be at 0. For x equals 7, it's plus 1 right here and plus 2 right here. This is 2 right here. So therefore the superposition would be 3, and so on and so forth. This is a better graph to show the superposition right here. Now the next question asks us to sketch the snapshot graph of the medium at t equals 4 seconds if the end of the medium at x equals 10 meters is free. Now we do basically the exact same thing as the first question, except instead of inverting this part of the graph, this green part of the graph, we simply let it be reflected back. So we basically just only change the x direction of it, not the y as well. So this is it right here. And our superposition would be also the same way as we did our first one. So it would be the addition of subtraction at each point. So for here, it would be plus 1 and plus 1. As you can see that the green and the blue are on top of each other. So therefore, our superposition would be 2. Again, right here, it's negative 1 right here, and then it's plus 2 right here. So our superposition would be plus 1, and so on and so forth. Here's a better description of the graph right here of superposition. And now I'll go on to Luke, who will give us problem number B.
Graph of the medium at x equals 4 if the wave travels to the right at 0.5 meters per second. So here's our graph of B right here. We've replicated it right here, and the wave is traveling to the right. We're interested in the point at x equals 4 meters. We want to make a history graph of this point at x equals 4 meters if the wave travels to the right. So we're going to watch this point at x equals 4 meters and watch its displacement as the wave travels to the right. So at 0 seconds we notice that the displacement of this point is 0. Then at t equals 1 second, the graph has moved to the right, half meter, and it's still at 0 meters with y displacement. Then it moves at t equals 2 seconds. It moves again half second to the right. Its displacement is at negative 1. At t equals 3 seconds, it's at negative 2. At t equals 4 seconds, it's at negative 3. At t equals 5, it's up to 2 meters. At t equals 6, it's back down to 0. and it will also be at 0 for 7 and 8. So here we made a little table of time and the position of that point at t equals 4. And we make a new graph of that, of time and its displacement. And that gives us a history graph of the medium at x equals 4. Now, for second part of B, we need to sketch a history graph of the medium at x equals 0 meters. The wave travels to the left at 2 meters per second. So we start with the same graph, but now the wave is traveling to the left. Its velocity is to the left, and we're interested in the point at x equals 0 meters. So we'll notice that when the wave travels to the left, this point will just follow how the wave goes across, except that 2 meters per second. So in fact, when 1 second passes, the wave will have moved to here. When 2 seconds have passed, it will have moved to here. This gives us the resulting graph. It looks exactly the same as the other one, except that the units are different, and it goes from 0 to 2 seconds instead of 0 to 4 meters. We have 0 to 2 seconds, and that gives us the graph.